Okay, students, now comes question number 4. It says you are given the function y equals x squared minus x squared, or asked to find the domain in the symmetry of this function, the critical point, the interval of monotonicity. Okay, so in order to answer this, what you need to do is this: the domain of this function is nothing but it is a function. It is a set that can make this defined. So you are free to take any number in place of x except those values that make this 0, right? So 1 minus x squared gets 0 when x is either 1 or minus 1, right? So the set of all real number except 1 and minus 1 is the domain of this, and the function satisfies this behavior. F of minus x is the same as f of x, okay? F of a negative number is the same as f of that is a positive number of the negative one. So f is symmetrical with respect to y-axis. That is to say that it is enough to sketch one part of the y-axis, okay, either the left or the right. Simply, you see, taking the image of one of the two, you can obtain the other part. So f is symmetrical with respect to the y-axis. And coming to the second one, you are asked to find the critical point, and the critical point is nothing but it is obtained. It is a point where you can have first derivative. You see a 0, or is a place where you can have the first derivative not defined, provided that the number is within the domain. Okay, so let's find the derivative of this one. The derivative of this can be obtained this way. You just apply quotient rule. First derivative the x squared, it will be 2x, and it will take 1 minus x squared as it is, and have minus here, take x squared as it is. Now we need to find the derivative of 1 minus x squared is minus 2x. And then the denominator must be squared, 1 minus x squared, the whole squared. So simplifying this, you will get this to be 2x, because 2x times 1 is 2x, whereas this is minus 2x cubed, right? It will be minus 2x cubed, and here also plus 2x cubed. So minus 2x cubed is cancelled by positive 2x cubed. You are left with 2x alone, 1 minus x squared, the whole squared. So try to now find the value of x that makes this 0, and this is nothing but it's a critical number as long as it is in the domain. So if the derivative at x is 0, if you see you are having this, applying crisscross multiplication, you finally obtain 2x 0. So dividing both sides by 2, x equals 0 can come. 0 divided by 2 is 0. So 0 is in the domain of the function. So 0 is a critical number, okay? So 0 is your critical number. So the critical point is the point which is obtained by taking the critical number and f at the critical number. So this is 0, and f at 0 is obtained simply putting 0 here in place of x. 0 square over 1 minus 0 square is 0. So 0, 0 is a critical point. The origin is a critical point. So up next is question number, question number 3, Roman number 3. You are asked to find the interval of monotonicity, that is to say increasing as well as a decreasing interval. And to gauge the interval of monotonicity, we do have two types of cases. One is interval of increasing, the other one interval of decreasing. The interval of increasing comes when the first derivative is positive. So the first derivative comes to be now, here it is obtained 2x over 1 minus x squared, the whole square. This is always positive, students, in its domain, because we are having square here. So though we are unable to use 1 in the minus 1, so this is always positive. So the ratio to be positive, necessarily x must be positive. That's why I'm having here x greater than 0. So when we take interval into account, so you are going to consider every value greater than 0 within the domain, but 1 is excluded because 1 is not part of what, students? 1 is not part of its domain. So the interval is going to be from 0 to 1 to union 1 to infinity. So within this interval, the graph is increasing, okay? The graph is increasing, and the graph gets decreased, or the function gets decreased when the first derivative is less than 0, and this is attained when this is less than 0. As I said earlier, the denominator is positive. For this to be negative, necessarily 2x must be less than 0, so divided by 2, x must be less than 0. So again, you are considering negative values, but the minus 1 or negative 1 has to be rejected because it's not part of the domain. So try to write now an interval excluding minus 1, and this is nothing but it is this. Minus infinity minus u1 union minus 1, 0 is the interval of decreasing. Now what comes next is question number, continuation from the question number 4. The Roman number 4, you are asked to find local extreme value, if any, and Roman number 5, behavior of concavity, and the last one is to find the inflection point for this particular slide. So in order to find the local extreme values, you see, you have to first know what the derivative of the function is. We have obtained that to be this, and clearly, as you see, you have to identify where the sign of this first derivative is going to change. Clearly the denominator is always positive in its domain, so but if you are using, you see, negative here, the output is going to be negative, and to the right of 0, if you are using positive value, you see the numerator is positive, the denominator is positive, you are going to have a positive output. So around the critical point 0, you are having now two sign changes on this derivative, from negative to positive, right? From negative to positive. So if at 0, at that particular number, critical number 0 is a local minimum value, because your derivative changed from negative to positive around 0. But there will never be any situation where you can have, you see, the derivative being changing from positive to negative. So we don't have local maximum in the case of this, okay? We only have local, what? Minimum. So when we come to the discussion of concavity, which is the second derivative that needs to be involved here. So when you are carrying out the second derivative of this using quotient rule, guys, remember quotient rule. Applying quotient rule, this is going to be like this. The derivative of 2x is 2, as you see, and we will take this one as it is taken, and minus. Now 2x is taken as it is, and look, 2x is taken as it is. Now it's what's turned to be derivated? It's the denominator's turn, right? So using quotient rule, 2 comes down. Look, so it's coming here. 1 minus x squared times the inner one must be derivated minus 2x. So divided by the square of this expression, so you are having now this expression being squared. Now simplifying this, what's going to come in this? What has been done here is 2 into 1 minus x squared is taken as a common out. So as you are taking 2 into 1 minus x squared, you are left with 1 minus x squared, plus here 2 into 1 minus x squared is taken out, so minus 2 times 2 is negative 4, but in here you have minus, plus comes plus 4x squared. And then look, 1 minus x squared can cancel 1 minus x squared here, so this turns to be 3 because we are having 4 here, but now this 1 minus x squared has cancelled 1 minus x squared. You are having 1 minus x squared to the power of 3, and then you don't have this expression, you are left with this expression alone together with number 2. Here it is. After simplifying this, 2 times 1 is 2, and this is minus 2x squared plus 4x squared, which makes 2x squared, and this is cubed. So clearly, as you see, this is always positive. This is always positive, so analysis is done on the denominator, right? So, as you see, the second derivative comes positive if x is within the interval minus 1 to 1. Look, it's always positive, guys. So if you are taking in different values within the interval minus 1 to 1, this turns to be positive. So clearly, the graph is concave up. Okay, concave up for this particular interval minus 1 to 1. And if the second derivative comes less than 0, if x is within the interval of what, students? Within this interval, because this gets negative if you are taking different values, you see, outside of this interval minus 1 to 1, okay? Because the numerator is always positive. If this is, you see, negative to the power of 3 is a negative number. So positive divided by negative makes negative. So within this interval it is concave down, okay? Concave down. Can we have inflection point for this? We don't have, because no value makes the second derivative 0, right? Because it is already a positive value, so we don't have inflection point for this. So having this into account, what comes next is question number what, students? Question number question number 7 of question number 4. You are asked to find, you see, the graph of this one. So everything is now obtained. The x and y intercepts are clearly at the origin, because when x is 0, y is 0, and when y is 0, x is going to be 0. So the x and y intercepts of this particular function is going to be at the origin. So the graph crosses both axes at the origin. That is a way of saying that. And we need to determine the vertical as well as the horizontal asymptote, and for that you have to look for the limit of the function as x approaching to 1 from the right. So as you are approaching to 1 from the right, you see, one approaching 1 from the right is using different values greater than 1. So as you are using different values greater than 1, it will be, okay, this will be a number greater than 1. So 1 minus a number greater than 1 will be negative, right? It's always positive. Positive divided by negative is negative infinity. Great. Now again here, approaching to minus 1 from the right, you see approaching to minus 1 from the right, you are using numbers like negative 0.9. So when you square that, it will be a number less than 1. So 1 minus a number less than 1, it will be positive. So the numerator is always positive. Positive divided by positive is positive infinity. Come here again. As you are using, you see, as you are getting closer to number 1 from the left, you are using 0.9, something like that. When it is squared and 1 is deducted from it, it will be positive, okay? So positive divided by positive, positive. Same analysis can be done for these two to be negative. So you are having, you see, around 1 and minus 1, you are having either positive or negative infinity. So this shows you that x equals 1 is a vertical asymptote. But not only x equals 1, x equals minus 1 is also a vertical asymptote, okay? Even though it's not written, guys, check x equals minus 1 too. So x equals plus or minus 1 is the vertical asymptote. And as you are taking limit of this function as x going to infinity, you are having this to be minus 1 because, look here, the coefficient of this is 1 and this is minus 1. 1 divided by minus 1 is minus 1, okay? So y equals minus 1 in the horizontal asymptote. That is to say, as the graph you see goes far away from the y-axis, you see it gets closer to this line, y equals minus 1. So the graph looks like as you see. You see, students, we do have a vertical asymptote at x equals minus 1 and x equals 1. You see, we are having plus or minus 1 here as a vertical asymptote. And here also the horizontal asymptote comes, you see, at minus 1. So you see, as can be shown, the graph crosses the origin, as you see. And as we said earlier, it is increasing within the given interval, decreasing with the given interval too. So anyway, the graph looks like this. What comes next is question number 5, and you are asked to evaluate this. So simple. What we need to do is we need to apply those important techniques of integration. So for the first one, it's use integration by substitution. So let you use u to be cos hyperbolic of x. Its derivative with respect to x is a sine hyperbolic of dx. X dx. So this is the question we are having. So in place of cos hyperbolic, let you use a power of 4 can come, and sine hyperbolic x dx is du. So this is use a power of 5 over 5 plus a certain constant c, but we knew what u is. It is cos hyperbolic of x. So finally c plus cosine hyperbolic the power of 5x over 5 can come. And when you come to b, again, let you use u to be x the power of 4 plus 9. So d will be 4x cubed dx. So from this, 2 into 2x cubed dx can come. So dividing both sides by 2. You see what comes here is 1 over 2 du is 2x cubed dx. So the question, this is going to be now 1 over 2 times du, because 1 over 2 times du is 2x cubed dx, and here it's the power of 4 plus 9 is already u. So this is 1 over 2 ln u, ln actually absolute value of u, but not of using still absolute value because it's always positive. So this will be 1 over 2 ln of x the power of 4 plus 9 plus c. That is the idea. And coming to c, it says the integral from 0 to pi over 2 of cos square x sine cubed x dx is basically a definite integral. So again here we need to know, we have to use integration by substitution. Let u to be cos x, students. So we can write this first sine cubed x as sine squared x times sine x, okay? In doing so, we can now, you see, change this sine squared expression to cos squared expression. Later we can use u to be cos x, so that its derivative can be minus sine x dx, right? So once we have that, look, this can be changed to this one. We know that from trigonometric identity, sine squared x is 1 minus cos squared x. We are having sine x dx here. So this integration, now we're having this. So in place of cos x, let you use u. So du will be minus sine x dx. So from this, the integration goes like this. Now look, everything of x is now changed to everything of u. So when, look here, when x is 0, cosine 0 is 1. That's why I'm having 1 here, okay? When x is pi over 2, look, when x is pi over 2, cos pi over 2 is 0. So we're having 0 here. So this minus comes because of, you see, this minus sine x dx. So this negative, because of this negative, this minus is out. Then this is u squared, 1 minus cos squared is u squared du. But from the property of this integration, we can reverse these two and have positive 0, 1, u squared 1 minus u squared du, because this is negative, we can reverse it. And this makes what? U squared minus u the power of 4 du. And we know u squared is u cubed over 3 minus u the power of 5 over 5 from 0 to 1. As you are substituting this, what you can get is 2 over 15.